continuing towards the next topic, that is pressure. Yes, we have learned about force and its effects and its various examples. Then, what is pressure? Are these two things equal or different? Yes, of course, they are different. That is why we are reading this chapter, pressure. Okay, so tell me students, if you are holding your pencil like this and this is not sharp from both sides, one side of the pencil is sharp and the other side of the pencil is blunt. So, you are providing a force from the both side. Okay, this is one example. And the another example is cutting a butter with a knife. Yes, are these two things equal? No. Okay. See, in first case, you can see here these two forces are not equal because one side there is a sharp point and another side is the blunt. And the other example, that is cutting a butter with a knife, that is actually a example of pressure. Why? Because we are using a sharp knife. Why we are not using blunt knife for cutting a piece of butter? Pressure, not only the example, the set of example that we are cutting a knife, cutting a butter with a knife, or the example of the force of that we are applying on some object. This is not equal to pressure. Pressure is various different things that depends on any other two factors. And these two factors are that the effect of forces produces depends on two factors, which are number one, magnitude of force, and number two, the area. Yes, the main factor is the area here. Yes, students, so now let us talk about first of all the magnitude of force. So dear all, the previous example, we have seen that there is a box and a student is applying a force from here. Okay, only one student is applying force from here. Let's suppose this is F1, and now the other student also come with the equal potential and again applying the same force, F2. Now, this box will move with a great velocity compared to the previous one. Yes, of course, now it will become F1 plus F2. So, magnitude is the amount. What is magnitude here? Magnitude is the amount. How much force is get to be exerted? Okay, this is amount. How much? Now, tell me which is greater, if a box is applied with one force only and if a box is applied with a two force, F1 and F2. Which is greater? Obviously, this one is greater. So, we can say that the magnitude of the force applied on this box is more compared to the previous one. Okay, now what about area? Applying force is also depends on area. Like, let's suppose we are taking this example, the example of brick. This brick is at vertical, in a vertical shape, okay, and one more brick is put on this second brick, okay, and the third one here is the brick again, which is in a horizontal part. Okay, now let me tell you students, if we are going to put these bricks on the ground, okay, like this and like this. So, which out of these bricks will cover the more area? Yes, of course, the more part of the area is covered by this because it is exerting here. This much of area is covered with this brick. But here in two cases, only this much part and only this much part with this brick. Okay now, so this is the area that is obviously on the surface. Fine. Now, why I am telling you this thing, dear all? Let's suppose all the force that are exerted by these bricks in three different examples are equal. But the area that is covered by these three bricks are different. So now the force is actually equally distributed over the area that is in contact with the surface. In the first case, only a small area is here. That is why the more force. Let's suppose we are taking the force F here for one condition and the third condition also. Okay. So F1 is here in the first case. So it is exerted in the single area like this. Small area, F force. And in third case, again, force 1 is this, but the area is large. So force is equal, but area is large. So this all force will be exerted on all area. It will be equally distributed in all area. But in second case, dear all, we are having F1 plus F1. That is 2F1. Okay, we are considering the force exerted by this brick is F1 now. That is why F1 plus F1 is equals to 2F1. So now, this area is again this small area like the first one. The area will be equal according to the first case, but the force here is double. So we can say that second case is having more pressure. That is why area is also dependent. Okay, now